So in this video, that is video 9 of research methodology and IPR, we will be starting up with module 3, which basically deals with sampling, the meaning of sampling, concepts involved in that, the types of sampling, and which includes both probability and non-probability sampling. So in probability sampling, we will be learning about simple random sampling, systematic sampling, stratified random sampling, and cluster sampling as well. Whereas in non-probability sampling, we'll be learning about convenience sampling, judgmental sampling, snowball sampling, and quota sampling. Again, at the end, we'll be learning about the errors which are included in sampling process. So this part, that is the entire sampling chapter, is kept in view after we've already learnt about the research design and calculating the hypothesis or formulating the research question and then calculating the hypothesis and then deciding about the sampling unit or the sample design or the sample size or the sampling method or sampling tools even for that matter. So coming to the sampling design. So what do you mean by a sample design? See, all items in any field of inquiry constitute a universe or a population. A complete enumeration of all items in the population is known as census inquiry. And coming to the sample, what happens is, see, you taking out a precise number of people or respondents from that particular population is nothing but a sample. However, it needs to be emphasized that when the universe is a small one, it is no use resorting to a sample survey. When field studies are undertaken in practical life, considerations of time and cost almost invariably lead to a selection of respondents, that is, selection of only a few items. The respondents selected should be as representative of the total population as possible in order to produce a miniature cross section. The selected respondents constitute what is technically called a sample. So in this sample, what happens is the survey so conducted will be called as a sample survey. Algebraically, let the population size be n, and if a part of size n which is less than n of this population is selected according to some rule for studying some characteristics of the population, the group consisting of these n units is known as sample. So he must prepare a sample design for a study, that is, he must plan how a sample should be selected and of what size such a sample would be or should be. So implications of a sample design. A sample design is a definite plan for obtaining a sample from a given population. It refers to the technique or the procedure the researcher would adopt in selecting items for sample. So sample design may as well lay down the number of items to be included in the sample, that is the size of the sample. Sample design is determined before data are collected. There are many sample designs from which a researcher can choose. So they are relatively more precise and easier to apply than others. So basically, sample design is a specific plan for obtaining a sample from a given population. It refers to the technique or procedure the researcher would adopt in selecting items for the sample from universe. So what are the characteristics of a good sample design? It should be a true representative of the whole population. It should be appropriate. It should contain or it should address to appropriate sample size. Sample should be chosen properly by appropriate sampling technique, and a perfect mix of all the population elements should be there in the sample design. So next is, while developing a sampling design, the researcher must pay attention to the following points. So what exactly is that? So he has to look into the type of universe, that is, see, these are the steps which are there in the sampling design, right? So we will go one by one with that. That is defining the target population or universe. So the first step in developing any sample design is to clearly define the set of objects, technically called the universe, to be studied. The universe can be finite or infinite. In finite universe, the number of items is certain, But in case of an infinite universe, the number of items is infinite. That is, we cannot have any idea about the total number of items. The population of a city, the number of workers in a factory, and the like are examples of finite universe. Whereas the number of stars in the sky, listeners of a specific radio program, throwing of a dice, etc., are examples of infinite universe. So, the first step being you will be defining the target population or the universe. And next is determining the sampling frame or source list. It is also known as sampling frame from which sample is to be drawn. It contains the names of all items of a universe in case if there are finite universe only. If source list is not available, researcher has to prepare it. Such a list should be comprehensive, correct, reliable and appropriate. It is extremely important for the source list to be as representative of the population as possible. So this was about the second step. And next, see, when you are determining the target population, an element is the object about which or from which the information is derived. So sampling unit is an element or a unit containing the element for which you are going for the sample, right? And it should be defined in terms of elements, sampling units, extent and time. Suppose that Revlon wanted to assess consumer response to new line of lipsticks and wanted to sample females over 18 years of age. Here the sampling unit would be households and all females over 18, and each selected household would be population element. Extent refers to the geographical boundaries and the time factor is the time period which is under consideration. For example, for a study of customer satisfaction, elements would be customers and extent is Bangalore city, time is 2023. When in the second step, as we saw when you're determining the sampling frame as we saw is a representation of the elements of the target population. It consists of a list or set of directions for identifying the target population. Examples of a sampling frame includes the telephone directory, an association directory listing the firms in an industry, a mailing list purchased from an organization, a city directory or a map. For example, you want to learn about scooter owners in a city. What do? You go to the RTO office. It will be the frame which provides you names, addresses and the types of vehicles possessed. So out of that, you will be calculating or you will be taking out the sample or the sample size. Students are the respondents and then college admin data will be your sampling frame. And the third step being specifying the sampling unit. A decision has to be taken concerning a sampling unit before selecting the sample. So sampling unit may be a geographical one such as state, district, village, etc. or a construction unit such as house, flat, etc. or it may be a social unit such as family, club, school, etc. even, or it may be an individual for that matter. The researcher will have to decide one or more of such units that he has to select for his study, and then he can go with the sampling units. For example, if retailers are to be contacted in locality, they will be the sampling units. That is the number which you give. Next is the size of the sample. So this refers to a number of items to be selected from the universe to constitute a sample. So this is a major problem before a researcher. The size of the sample should neither be excessively large nor too small, but it has to be optimum. An optimum sample is one which fulfills the requirements of efficiency, representativeness, reliability and flexibility as well. While deciding the size of the sample, researcher must determine the desired precision as also an acceptable confidence level for the estimate. The size of the population variance needs to be considered, as in case of larger variance, usually a bigger sample is needed. The size of population must be kept in view, for this also limits the sample size. The parameters of interest in a research study must be kept in view while deciding the size of the sample. cost to dictate the size of the sample that we can draw. As such, budgetary constraint must invariably be taken into consideration when we decide the sample size. So this was about the sample size, and next is the parameters of interest. In determining the sample design, one must consider the question of the specific population parameters which are of interest. For example, we may be interested in knowing some average or the other in estimating the proportion of persons with some characteristics in the population, or we may be interested in knowing some average or the other measure concerning the population. There may also be important subgroups in the population about whom we would like to make estimates, right? So all this has a strong impact upon the sample design we would accept. Coming to the budgetary constraints. So before that, selection of sampling method. The researcher must decide whether to use Bayesian or traditional sampling approach to sample with or without replacement, and to use non-probability or probability sampling. In probability sampling technique, sampling units are selected by chance. Yes, there are chances of getting, the probability is more. There is no biases involved at the time of selecting the sample, and each element is getting a fair chance to be a part of the sample. In non-probability sampling technique, the sample is selected based on personal judgment of the researcher and not chance. So thus some biases will be or may be involved in this. And then it's like he must select the design which for a given sample size and for a given cost has a smaller sampling error. He has to look into the error which might occur during the sampling process also. And the last step will be the budgetary constraint, like cost considerations. From practical point of view, we have a major impact upon decisions relating to not only the size of the sample but also to the type of the sample. So this fact can even lead to the use of non-probability sample. So these are the 7 basic steps of creating your sample design, wherein you cannot skip any of the step, because see, you have these steps which are linked to one another. That is, you cannot skip them because you have to follow it in an order or in a line, right? Criteria of selecting a sampling procedure. So what are the different criteria? See, a researcher must remember that 2 costs are involved in a sampling analysis. That is, the cost of collecting the data, yes, and the cost of an incorrect inference resulting from the data. That is very much pretty sure, right? So here, what is that is, researcher must keep in view the 2 causes of incorrect inferences, that is systematic bias and sampling error. A systematic bias results from errors in the sampling procedures and it cannot be reduced or eliminated by increasing the sample size. At best, the causes responsible for these errors can be detected and corrected. Usually, a systematic bias is the result of one or more of the following factors. First one being the inappropriate sampling frame. If the sampling frame is inappropriate, that is a biased representation of the universe, it will result in a systematic bias. Defective, the second point being defective measuring device. If the measuring device is constantly in error, it will result in systematic bias in survey work. Systematic bias can result if the questionnaire or the interviewer is biased. Similarly, if the physical measuring device is defective, there will be systematic bias in the data collected through such measuring device. So it is dependent on the measuring device whether it is correct or a defective one. So first one being inappropriate sampling frame, and the second one being defective measuring device. And then the third point being non-respondents. If we are unable to sample all the individuals initially included in the sample, there may arise a systematic bias. Yes. The reason is that in such a situation, the likelihood of establishing contact or receiving a response from an individual is often correlated with the measure of what is to be estimated. So, the fourth point being indeterminary principle. Sometimes we find that individuals act differently when kept under observation than what they do when kept in non observed situations. For example, if workers are aware that somebody is observing them in course of a work study, on the basis of which the average length of time to complete a task will be determined, and accordingly the quota will be set for piece work. We would have learned piece work and time work, right? They generally tend to work slowly in comparison to the speed with which they work if kept unobserved. Thus, the indeterminacy principle may also be a cause for a systematic bias. The fifth point being natural bias in the reporting of data. Yes, so what do you mean by this? Natural bias of respondents in the reporting of data is often the cause of a systematic bias in many inquiries. There is usually a downward bias in the income data collected by government taxation department, whereas we find an upward bias in the income data collected by some social organization. So people in general undertake or understate their incomes if asked about it for taxpayers, but they overstate the same if asked for social status or their affluence. Generally, in psychology, what happens when they conduct survey, people tend to give what they think is the correct answer rather than revealing their true feelings, right? Sampling errors are the random variations in the sample estimates around the true population parameters. So, what happens is, since they occur randomly and are equally likely to be in either direction, the nature happens to be of compensatory type and the expected value of such errors happens to be equal to 0. So, sampling error decreases with the increase in the size of the sample, and it happens to be part of a smaller magnitude in case of homogeneous population. Sampling error can be measured for a given sample design and given sample size. The measurement of sampling error is usually called the precision of the sample plan. If we increase the sample size, large size sample increases the cost of collecting data and also enhances the systematic bias. So, thus the effective way to increase precision is usually to select a better sampling design which has a smaller sampling error for a given sample size at a given cost. In practice, however, people prefer a less precise design because it is easier to adopt the same, and also because of the fact that systematic bias can be controlled in a better way in such a design. So, in short, while selecting a sampling procedure, the researcher must ensure that the procedure causes a relatively small sampling error and helps to control the systematic bias in a better way. So we still have different types of sampling designs and characteristics of a good sample design. It includes the decision on the sampling unit, the sampling size, and the sampling method. Sampling unit is the most elementary unit which would be a part of the study. For example, in a survey on newspaper readership pattern, single household comprising of all the members of the household can be regarded as a sampling unit. Yes, because it is a representative of that entire population. The size of the sample depends on factors like the availability of time and funds to the researcher, the ability of the researcher, the size of the population, and the nature of the population. How to draw a sample? Probability method of sampling involves giving every member a known and unbiased chance of being a part of the sample. In non-probability sampling method, an element of bias has always be included. The probability of a unit being a part of the sample will not be known. The sample design to be used must be decided by the researcher taking into consideration the nature of the inquiry and other related factors. So this was about the method of drawing a sample. So again, here is a pictorial representation of your entire total population and the sample you are taking from that particular population. So basically, sampling means selecting the group that you will actually collect data from for your research. If you are researching the opinions of students in the university, you can always survey a sample of 100 students. So sampling allows you to test a hypothesis about the characteristics of population. So in this video 9, we have just started module 3, wherein we have touched upon the sample design, sample procedure, how to select the samples and all, right? So in next video, that is video 10, we'll further continue with different types of sample designs, characteristics of a good sample, and so on. Thank you.